Alright, so for the first set of problems, I ask you to factor each of them and see what is unique about the two sets of equations, one on the left compared to the ones on the right. When you finish factoring the problems, please turn the video back on. So we look at the equations, what appears to be unique about the equations on the right in comparison to the ones on the left. I'd like you to think about it. Maybe in the left margin, write down your thoughts. So hopefully you decided that what's unique about the equation on the right is that both factors are the same factor. And so because of that, we could actually simplify each of these one step further by rewriting them with an exponent of 2. By rewriting them with an exponent of 2, we're actually rewriting these in what's called vertex form. In all cases, the vertex, the y value of the vertex would be 0. But anytime we have y is equal to x minus h quantity squared plus k, that's called vertex form. And so all those equations on the right are in vertex form. Ones on the left, because the factors are different, in factor form we can tell where the zeros are at, and these would have two different zeros. So the first one would be 0 of -5, and the second one, the 0 would be 2. Here would be 2 zeros would be -1, which makes it 0 for the first parenthesis, and -4 for the second. The equation on the right, there actually is only 1 0. For both 2 0 for the first one. The second one, both zeros are -3 0. And for the last one, both zeros are 4 0. So where the equations on the left where you have a parabola that's going through -5 and 2, going through two different times, different locations, the equation on the right, the parabola is actually sitting, the vertex of the parabola is actually sitting on the x-axis. It touches at one time. So again, those are some of the unique things about the equations on the left side compared to the right. And the biggest thing is the fact that all the equations on the right have two factors that are identical, and the ones on the left do not. So please factor the equations and decide which group each equation fits into. Is it along the set on the left or the set on the right? And then at the bottom, they'd like you to finish the equations off so that they would actually end up being the equations on the right. When you're finished, turn the video back on. So using our diamond rectangle approach, we'd end up with the first equation having two different factors, which puts it in the left group, and then the next two equations have identical factors, which means we can write that with an exponent of 2, and that makes it into the right group. The next three equations, they want you to figure out how to finish it off so that the equation you have actually makes it into the right group. If you're not finished with that, finish those problems off. If you are, then continue listening to the video. So to help with the finishing off the equations, I want to go back to the work you did with the GeoGebra activity involving building perfect squares. So we have an x squared, and we have one x tile on each side to make it an x plus 1 and an x plus 1. So that means that to finish this off, we're going to have a 1 by 1 square in the top right hand corner, which makes it plus 1 finishes it off, so it fits on the right side, and both factors are going to be x plus 1s. For the x squared minus 20x, so we have x squared. To split it up, we need a -10x on the top, a -10x on the right hand side. So that would make it an x minus 10 and an x minus 10. And to finish off the top right corner, we have a 10 by 10, 10 times 10, which is 100. Now both 10s are negative 10s because of the -20x, but -10 times -10 is still going to be a positive 100. And the two factors again are both x minus 10, so that would be x minus 10 squared. The last one, we have an x squared. In the top right corner, we know that we have 49. So we've got to figure out how many x's do I need to get that 49. And that would be 7 each, because 7 times 7 is 49. So we have an x plus 7 on the left, and x plus 7 on the left, and x plus 7 on the bottom. So to finish this off, we need 14 in the middle, and then the two factors would be x plus 7 squared. So one thing to keep in mind as you're working through completing the square is the amount of x's that you put on the top and on the right are the same number, because you want to make sure that the dimensions of the rectangle are the same. So on page 2, you're given some directions on how to change a standard form equation into a vertex form. Please understand that all standard equations have a vertex form because every parabola has a vertex. Not every parabola can be factored. Sometimes a parabola can have a graph that never touches the x-axis. Let's say the graph is going up and the vertex is at 2, 2. And if the parabola is going up and the bottom of the graph is at 2, 2, it will never touch the x-axis, which means it cannot be factored, because factored parabolas or factored equations for parabolas tells us the zeros, and the zeros is where the parabola intersects the x-axis. Sometimes that doesn't happen, but with standard form, all standard form equations can be rewritten in vertex form because every parabola has a vertex. So go ahead and look at the steps and see what the steps are asking you to do to be able to turn this thing into a vertex form. And then when you're done, take a look at the problem on the bottom and see if you can follow the steps to complete that problem. When you're finished, turn the video back on and we'll go through the problem together. All right, so step 1 is we want this part of the equation to remain on the right side. We're going to subtract 14 from both sides. So you have y minus 14 equals x squared plus 8x. And we want to complete the square. So to do that, we have an x squared, and then we have split the 8x up, so we put 4 x's on the top, 4 x's on the right, and we're going to finish off the square here. And that square would be a 16, because we're going to have x plus 4, and on the bottom an x plus 4, and we're basically multiplying 4 times 4 to get the top right corner. So we're going to be adding 16 to both sides. On the left side, that is with y plus 2, when we add the 16 and the negative 14. And on the right side, we're going to write this as our two factors. So we have x plus 4, and we have 2 of those. So it's going to be x plus 4 quine squared. Just keep in mind, we're trying to write this thing in vertex form. So in vertex form, it is going to be x minus h quine squared. So it means our two factors of our rectangle should be identical, and then plus the k value. Now, to get the final equation, we need to get y by itself. To do that, we need to subtract away the 2. So we end up with this y is equal to x plus 4 quine squared minus 2. The vertex for this parabola would be at negative 4, negative 2. Keep in mind that if I stick negative 4 into the parenthesis, I should get a 0. So negative 4 plus 4 is 0. So if you graph y equals x squared plus 8x plus 14, the bottom of the graph should be at negative 4, negative 2.